In this set of videos, we're going to go over using the KiCad PCB design software toolchain to generate a schematic and then from that a PCB of a circuit. This is not meant to be an exhaustive tutorial of KiCad itself showing every nook and cranny and piece of KiCad, but instead it's designed to be a more basic, straightforward walkthrough demonstrating everything from beginning to end of generating this circuit.
In fact, the design we're going to do is made from this very rough sketch. You can see here. So this very rough sketch is just the basic way that I would begin a design. I had a need for a system that could take in USB power to charge a LiPo battery, specifically a 18650 LiPo cell, and then boost that up to 5 volts to then power just a simple Mega 48 chip, as well as additional systems that might need 5 volts. The idea behind this is I really want to make the form factor basically the same size as the 18650 battery, but maybe just a little bit thicker in one dimension, trying to really stick to that as the form factor. So the way I did this is I went and I hunted around for a couple parts I knew I needed. The first thing I needed was a LiPo charger. In this case, we're currently going to use the MCP 73811, which might change partway through this design process. And then that's going to charge a LiPo battery, which is kind of in the middle. You can kind of see it here, this zone where the little hand is wiggling. There's the LiPo connector, as well as an additional connection. And then we're going to have a boost converter. I wanted to try to find a multiple amp boost converter, but it turned out to be really a challenge when I was dealing with 3.7 volts to find one that could do multiple amps as well as be a simple implementation. Because I knew I was also going to use this design for doing this series of how to use KiCad. So I ended up with this part, which is the MCP 1642- something or other. We'll definitely find that in more detail as we look at the data sheets. In terms of what it was going to run, I went around and around on this. I considered an ARM processor. The TechBots library, which I'm going to show you, does have an ARM processor in it. It's plenty powerful, has a lot of features and functions, and there are actually some really good libraries for using it. But at the end of the day, I decided to go with something that I knew most people would have more experience with rather than something that was a little more cutting edge. Which was decided to go with an Atmel processor, specifically a Mega 48, just a 32-pin version of it. But one of the trade-offs for that is to program it. I don't get any fancy programming. I can't just plug it into USB and download. Instead, I went with a tried and true original, a 6-pin AVR ISP programmer. And you can see that 6-pin programmer right here. From there, I broke out as many pins as I could. I'm planning to put them all in 0.1 inch header on a 0.1 inch grid. So this, in theory, would allow me to plug it into a white breadboard or something of that nature to allow me to actually interface parts to it as I went and did this. So this is just my basic design. This is where I got started. I have a couple ideas in terms of what type of connectors I want, like a USB micro connector, even some specific numbers for certain connectors, like how I'm going to hook to the battery. Is this 36-54-ND. I'll need 2 of them. There are battery clips just for the ends of the battery. But this is kind of, and then the specific crystal. This is just where we're going to get started. So jumping into KiCad. So all I did is I've already downloaded the KiCad library for ECE 34X, so that's available to me. And I've just opened up KiCad. I have an existing project here, but I'm going to start with a new one. So I'm going to go ahead and add a new one. And I could try to do it from a template, which I'll just show you what that would look like. But I need to find a spot to put it. So in this directory 342, I've already kind of put my KiCad library local to where I'm going to be doing all of my KiCad projects. And I'm just going to add a new folder, which I'm going to call V2, just because it's going to be my second version of this board. And I'm going to go ahead and stick my information inside of that. Now, because I chose from template, one of the neat things is that KiCad actually gives me some basic templates. So if I want to, for example, make an Uno shield, I could start with this as my basic framework, and I would know that this is dimensionally accurate. Of course, I'm trusting KiCad to be accurate, but a lot of people have used this, so I feel pretty confident that my pin pitches and my design would be accurate. I could also do it for a variety of other boards, even the BeagleBone, Raspberry Pi. I don't know which version this is, but likely it's the one. Hard to know. 2012, so it probably is the Raspberry Pi 1 or the 1B. And then even some of the Discovery boards from STM. So all those. But since I'm actually not going to do that, I'm just going to click cancel. And it went ahead and still created my new project we can see here. Project composed of two different parts. A schematic, as you're again, and the PCB. So in our case, we're just going to open up the schematic. And as we would expect, we have a blank document to begin. Again, this is not an exhaustive tutorial at all of KiCad. It's just a kind of a walkthrough of building this one particular board. But briefly, there's a way to turn the grids on. You can set whether you're in millimeters or inch units. You have the ability to add buses and lines and name nets, add text, etc., etc., add components, which is going to be used a lot, what we're doing here. As well as a variety of things buried in the menus. The first thing that I want to make sure of is that I have my libraries set up. So to do that, that's a Preferences, Component Libraries. And if we look around here, I've already actually added, no, actually, excuse me, I have not. This is not aware of the 340X libraries. So to do that, I need to go ahead and add a search path. And that's going to be in this KiCad library here. And specifically, I'm going to add the component library. So once I've selected this folder, you'll see that I now have the ability to, here we go. It wants to tell, first wants me to do if it's a relative path. This would be so that I could then move this whole directory structure around anywhere in my hard drive. I would always want to do that. So I'll make it relative. Notice that it doesn't say something like C:, blah, 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 blah. It says, it starts with that relative coding. And then from here, I'd want to actually pick the lib file. So I'm going to have to browse for that. You're going to see here. So there's this .lib file. So this was in the directory I'd previously included in the path. And now I have access to the .lib file itself. And that should show up right here at the bottom to begin with. Since I know I'm going to be using a lot of parts out of it, I'm going to go ahead and just move that bad boy all the way to the top of the list so that I'm sure that it's easy to find and that the parts in this library, if they happen to have a different name, or excuse me, if they happen to have the same name as a part in another library, we'll use my version first. I have a design philosophy I like to follow. This philosophy is that I can find parts anywhere on the internet. I can make my own parts. I can do all of those bits. I can do that. But once I have personally used a part and I know the part is good, I make sure that the version of part I used on my board is copied into my own library and I'm in control of it from there. This is a very useful thing to do because you're going to find a lot of parts and pieces you'll find in random places or you'll be given by others, even professional engineers that you might work with at your future company, are going to have little bugs and quirks. I'd rather fix those myself and then be in control to make sure that I don't lose those bugs and quirks show back up again. Anyway, so I've added the top. Okay, I'm good to go. What this does is this, when I add a component now onto the screen and it loads up the libraries, I can actually find the ECE34X component library here, and I have a lot of parts available. One of the things we've done is we've tried to go out of our way to make sure that all of the parts listed in this component library are available for sale locally here at the in the TechBot store. It's not guaranteed, but most of them are. That being said, they're also supposedly accurate. Okay. As I just talked about, though, you always would want to double check yourself, but we've done our best to make sure these components and their associated PCB layouts are as accurate as possible. Starting out, So let's throw down our first part. So I want this MCP 73811. So to get my hands on that, MCP 73811, that looks about like it. And drop my part into place, and then go ahead and grab the next one.